Welcome to Physics Can Be Fun with me, Stephen Thomas. Now, physics can be fun, but I've taught a lot of students this year and not one of them said to me, I think physics is great, I want to do physics for the rest of my life. Most of them, their attitude was, I want to finish this year's matric physics and I want to get the hell out of physics and never see it again. Unfortunately, that's the case, but don't blame me. They were like that before they came to me and I never managed to convince them otherwise. But today I want to talk about a revolution in the teaching of science. This is not something, mark this day as the day that the revolution in science teaching happened. Now, I was teaching in Mitchell's Plain, Lentegeur, when an epiphany occurred. The great theory of evolution came upon me, and I was struck by time and chance, and it came to me why science teaching is so dreadful. And that is what I want to share with you, the great revolution in science teaching. Now, first, how much do you own? Just send me all your money and I will let you know. No, there's much more to it. Let me share it for free. Most science teaching is just teachers talking. Then kids reach for a calculator. Second half of the lesson, blah, 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 blah. They do problems. Frankly, we are spending our science time doing bloomin' maths. Who cares about maths? Maths is a tool. What do I feel about my tools? My hammer, my saw, my welder? They tools. I have no interest in them. I have interest in the beautiful things I can make with my tools. So science and physics can be and should be the fun thing. And yet we've turned it into this dreadful, dreary science teaching. Calculate, clickety, 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 click. That, folks, is not science. Now, when I was a tiny little boy about 100 years ago, it was a long time ago, science teaching used to be actually quite interesting. We'd walk into the lab, there'd be smoke billowing out of it, the teacher just dropped some sodium into water, or we'd lit a bottle of oxygen and pop it. Glowing splint turned it back to fire again, or there'd be a slinky spring or a ripple tank, or we had fantastic equipment in the old days. And now you go to schools, it's a wasteland out there. You generally don't teach in a science lab. If you go to the science lab, it's all broken, lost, gone, locked away. There's not much stuff around. There's nothing to excite the students. So all we are left with is one baby boomer. That's me, the teacher, standing in front of the class. For 20 minutes, we teach the subject. Okay, vertical projectile motion. You throw stuff up, it comes down. Here's a whole lot of formulae. Find all the values, plug it into the formula. Okay, let's spend the next half of the lesson, the second half, let's all just practice vertical projectile motion. And that's just normal. This is the way we teach science. And come the end of the year, they've forgotten everything that they did in vertical projectile motion at the beginning of the year, because they're great at losing their notes and they're great at forgetting. And unlike us who were so scared of failing, failure, face my parents and tell them I failed science, face my friends who've moved on and now you're a failure, you failed science or you failed the year, now you sit with the junior kiddies and you're this big guy who's failed. No, the terror of failing was there, but there's not that same terror, so the kids don't really pull thumb out at the end of the year, pull out all the stops and go and take all those things that you've taught them during the year and then sit down for a week or two before the exam and just sit there memorizing and studying and doing past papers. No, it doesn't happen. So, with that in mind, what is the revolution in the teaching of science? Now, you will see I've got a web page here that's got my app, or this is actually a server-side web page, and what it does is it takes all the formulae that we're going to use in paper 1 And you don't have to spend the second half of the science period doing all the calculations and wasting half an hour actually practicing maths. I mean, let the maths teachers practice maths on their own time. What it does is you take the formula, you plug in the values for vertical projectile motion. So say you throw something up. Okay, let's choose up as positive. So I first say vector, up, positive. See, it's got an up and it's got a horizontal. So up is positive. Now we look for values. We plug in our values. Okay, let's say we throw it up at 15 meters per second. V initial 15. Okay, there's your one value. Write it down. Then acceleration due to gravity minus 9.8. Down because it's minus. So we've chosen up is positive, so gravity works down, must be negative 9.8. Let's see what it's going to be like when V final is 0, when it reaches the top. Okay, V final 0. How long has it taken to teach vertical projectile motion in that manner? We throw something up, that's V initial, 15 plus 15, reaches at the top where it's not moving at all, V final, 0, okay, fine. Acting under the influence of gravity, minus 9.8, fine, there's three values, we plug them into our formula. Now we don't have to waste, folks, 10, 15 minutes, kiddies get out their pencils, get out their calculator, have a little chat with their friends, sit down and calculate how long it's going to take delta t for it to come to a halt. We just go to my web page, plug in those three values, hit the done button, and boop, it kicks it out. Let's say it's 1.5 seconds that it takes, delta t is 1.5. All done in 5 seconds. Now we've got time to rehearse and go over question after question after question. And the part that kids find easy is the calculating. If they know they've got to look for a formula, plug in the values, do the calculation. Yeah, they just kind of get into the groove of doing that. It's not very exciting. They don't mind it and they don't hate it. It's just nothing to them. But it's just a time waster to us. We should be taking problem after problem. Okay, how? Here's the problem. Yes, it's a vector. Up is positive because that's the starting direction. A balloon's going up, a camera falls out. The camera's going up to start off with. Okay, so let's choose upwards. Positive. Get them active. Get them playing out and acting. Means it starts, it goes up, it reaches the point. Get them to act out the projectile. So there is the acting out the projectile. Then it's going to come down, then it maybe bounces again. Get them to act out and tell them that what they're acting out is a displacement time graph. So now they know that a displacement time graph for that problem, camera going up, reaches its apex, comes down, bounces once, and then comes to a halt. They've acted out displacement time graph. By acting out, it's gone into their minds, their memories, that, there we go. That is what it looks like. Now do this. That is a velocity time graph if up is positive. Take your right hand, do this at a diagonal down. Slope of the graph, 9,8. Do you notice that I haven't used a single note? Because kids write notes, file them away, because it's a note, they don't have to remember it anymore. They think they're going to come back to it at the end of the year and revise their notes. They don't. They've lost them, or they just don't do it because they don't mind failing. They're going to stay with mom and dad for 35 years, then they're going to live off SASA. So there's no fear of failure. So the important thing in this revolution of science is get it into your memory now. Spend the lesson not doing notes. I want it in here. You know, that old thing we used to call memory. Get it into memory. And get it now. Revise now. Go over 5 papers from day 1, minute 1. Start with question 1, November exam, whatever it was. Start with it and act out the problem. Use your arms and motion to show, okay, a velocity time graph always looks like this. A displacement time graph always looks like that if there's a balance. Or it acts out what the actual movement of the camera or whatever it is that falls out of a hot air balloon or a helicopter looks like. So now the kids are acting out. They're not sitting there with their calculators calculating things. They know we know they can calculate, right? They can change the subject of the formula, they can plug in values, they can crank the sausage machine handle or the calculator, they can spit out an answer of the sausage. Why are we wasting our time practicing maths in science lessons? So now if we act out the problem, so it's a vector, there's up is positive, this is your sign for positive, that would be your sign for negative, down is negative. Okay, now we write our values, then we go to our BFF. That's the symbol for BFF. We go to our BFF, we look up a formula that's got V initial 15, V final 0, and gravity or acceleration minus 9,8 down. It's all on our BFF. We act it out. There's our BFF. It's active. That's going into their memory. We're doing strange, crazy things. As I say, I'm possessed by the great theory of evolution. It has come upon me. I have had my Mitchell's Plain Lentahir experience when I was teaching these kids. It just came to me that this is the problem. We are getting them to sit there passively, write notes, do maths. No. And what are we going to do with all the time we now have left at the end of the lesson if we're not doing this? I say they can go home, and all the problems that you said, like this balloon problem, let them go home and do their maths on their own time at home for homework. Great! So what are we going to spend doing with the rest of our time? We're going to be doing interesting science. We're going to go and actually play with, let's say, we've got a little circuit here with electronics, and we've got the little chip here that makes it spin around and around, and we program this chip to do something. Or if we're doing vertical projectile motion, every kid and his dog has got a smartphone. So what do? We take a golf ball and we throw it up and it comes down. So here we got the golf ball. Oops, or there's our golf ball. And we, on our smartphones, we video it. We turn it into a YouTube video, and then if you press comma or plus on a YouTube video, you'll see the golf ball moving in little steps. Each frame is a step, and so you can plot your golf ball. So now imagine we spend the rest of the lesson, vertical projectile motion, plotting how far the golf ball moves in each frame. Say they're 30 frames a second or 16 frames a second, so we know it's 1/30th of a second or 1/60th of a second is the time between. And we have on the blackboard, we have a ruler with the little distances, so we can measure the distance that it moved in 1/16th of a second. The golf ball moved, so we know its velocity, we know its displacement, and so we can actually play with our YouTube video and our smartphone. I say that's all we need for the year, really. We've got our smartphone, it's got access to the internet there, it's got the formulae, the BFF or data sheet, it's got all my formulae there. You just pick a formulae, plug in your values, press done. 3 seconds later you got your answer. You knew it took 1.5 or whatever it took seconds to go from starting velocity of 15 to stopped. So what this revolution is about is we no longer are spending our time just wah, teacher, one baby boomer talking, 30 passive millennials sitting there doing clickety-clickety-click maths. We're doing some maths. We feel very satisfied, and we feel we're doing our duty by doing some maths. It's frankly why they're failing. It's rubbish. It's just not science. And then with all that extra time we've got, we're sitting there, we're taking YouTube video of an actual projectile, we're doing some actual factual science. And we're going to measure, we go to YouTube, put it on YouTube, we measure the distance as the golf ball, we watch its projectile, we see that it's symmetrical up, symmetrical down, displacements, same on either side of the curve, and so we do some actual science. Folks, that is all I can say in this 15-minute video on the new revolution in the teaching of science.